Good evening, guys. I welcome you all to the Intro to IoT and Robotics session 3, that is MicroPython and Circuits. I am Janvi, the core member of DSC-ASEB, here to, along with the technical team member Saket Chandra, to take you guys through MicroPython and Arduino circuits. So first, I'd like to start off by introducing Arduino IDE to you guys. So basically, this one is like an IDE stands for Integrated Development Environment. It's nothing but just an environment where you can write your Arduino program and you can connect your Arduino board and you can upload the code into the board so that you can successfully conduct whatever experiment you're trying to. So you can check in your chat box. There'll be two links, so I'll show you along with that. So this is the Arduino software. It's basically an open source software where you can download, so you people can like go to this thing and download. So I had already downloaded, so I have it already, and I'll also give you guys easier way to program in this one. So first I'll start off by explaining what this means. So every program in an Arduino is known by the name as sketch. So it is given as a default name along with the date. So here you have two programs. So one is void setup and void loop. So basically in void setup, all your input pins goes in there. So basically the structure of this set is that you have to put in inputs. So this is one setup and this is the other setup. So here in this setup you basically put in all your pin information, like from which pin you want the input and from which pin you want the output. But all such codes you put it up in your uh, void setup. And in void loop you basically put your function code or the program you want to learn in the void loop. So I'll be taking you guys more on that. So then we can go next. The tool which we would be using today is Tinkercad. So you guys can open Tinkercad and sign up for that. I'll give you like 1 or 2 minutes. So this is the online simulator we'd be using today. So here basically it's an easy drag and drop type. So you like can click and you can drag it here, and the code you can write the code here. And so this one is the simulation part where you can run your code. So I'll be starting ahead with that. So these are the circuits we'd be doing today. That is, first we'd be getting started to know what's a breadboard and how you can start building circuits with that, because the breadboard is like one of the most important component either when you're using an online simulator or an hardware. And then we'd be using a basic, starting with basic circuit like blinking of an LED in Arduino, and we'd move on with it. So this is basically a breadboard. So it is nothing but the pins are internally soldered like this way. So here the pins are, these are nothing but called as rail power lines, and these are known as the component lines. So these are internally soldered, and behind that they are generally covered with a soft material or like a double-sided tape or something for conveniency. So the power, so the generally the current passes through these power rails. So the current passes through these rails and they move all over the thing. But this does not have, this is like internally separated. So we use another two wires to connect these two. So basically, going into deep, these are nothing but the components present inside. They are designed in such a way that it holds the legs of the components firmly inside it. And firstly, like it was all based on wooden and all that, but they finally, with the arrival of new technologies, they have brought it down to this thing. So which is convenient and very easy to use with the hardware. So now I have a small video which you guys can check out. It's more about breadboard.
Hi, my name is Ian Buckley, and you are watching MakeUseOf.com. Today, we're going to look at breadboards, what they are, what they are used for, and without any further ado, let's just jump in. Breadboards are used to prototype circuits. If you've got a starter kit with your Arduino or Raspberry Pi, you probably have one. They come in many sizes. For the most part, the standard large size and a slightly smaller size are the ones you see the most, though some of them also come with binding posts for power sources as well. Regardless of which one you have, they mostly work in the same way. The bigger breadboards have lines running all the way down the longer side, which are known as the power rails. This is because you can plug your microcontroller or power supply into them to provide power to the components on the inside. Running perpendicular to these are the component lines, and these are where you place your components. This is where you can build your circuit. Smaller breadboards work exactly the same as the larger ones, though they don't have the power rails running down each side. By flipping over a breadboard and pulling off the backing, you can see how they work. These pieces of metal run all the way along the board and connect all of the components together that you need. If you were to pull out one of the metal lines on your breadboard, this is what it would look like. They're all small metal crimps that are designed to grab the legs of the components. This is why they're so useful. It means you can make circuits without having to rely on learning how to solder or using a soldering iron, and it's very easy to prototype things quickly. One other feature of the breadboard that you'll see is that down the middle there is a channel, and this channel is a specific size and for a specific reason. The reason that it's there is because many integrated circuits or chips comply to a standard called dual inline packages. So for example here we have an L293D motor IC. This is designed for driving motors in a circuit, and as you can see it fits perfectly over that little channel. So for an example of how a breadboard would be used, let's look at a simple LED circuit with an Arduino. Here you can see there are two LEDs. One of them stays on all the time, and that's because it is being powered from the power rails of the breadboard, and those power rails are connected to the 5-volt and ground pins of the Arduino. You'll see that the other LED is blinking, and that's because it's been connected to one of the output pins of the Arduino, which is running the standard blink sketch modified to output on one of the pins instead of the internal LED. You'll also notice that the power rails running along the bottom side also work, and that is because at the end of the breadboard we have jumped the positive to the positive line and the negative to the negative line, and this is just a general good practice that it's worth doing because it means that your components will always have power no matter where they are on the board. Just before we finish, one little bit of trivia. If you're wondering why this plastic device that you have that helps you make circuits is called a breadboard, it harks back to the history of DIY electronics when people also wanted to prototype quick circuits, but they didn't want to have to get a soldering iron out or anything like that. What they would do is they get an actual breadboard from their kitchen, and they would use that with their components along with some screws or some nails or some thumbtacks to make quick circuits just to test things out or learn about electronics. So that is, in brief, what a breadboard is and what you can use one for. I hope this has been useful for you. As always, there is a full article on the Make Use of website covering this. There'll be a link in the description for that. And thank you all so much for watching. Don't forget to subscribe to Make Use of for more weekly tech tips and giveaways.
I hope that was clear for you guys. So now we'll move on to creating our first circuit, that is blinking an LED using Arduino, or simple circuit using Arduino. So this is the simple circuit I created using Arduino. I'm basically giving a 9-volt power supply and connecting it to the positive and the negative of the a breadboard. So these are internally connected and these lines are internally connected. So first I'm taking a 9-volt battery, and from the positive terminal of this I'm connecting it to the positive terminal of the breadboard. So in this way it creates a charge where it can go inside, and the same with the negative. And now I'm using this component. So this component is basically called a resistor. So what resistor does are it limits the amount of current flowing into, suppose this, now here the component is LED. So here it resists the amount of current flowing into the LED, because if the resistor is not there, if we remove this, if there's a lot of current, suppose this is like some more voltage, so the LED might burn out. So we're using the LED here, we're using the resistor here, so that the LED doesn't get burned out. So this LED, this resistor will be connected to the cathode, and from the anode we're again sending the, connecting it to the positive terminal where the energy where the current passes through it. So now I click start simulation. You can see that the LED is blinking. So this is like one of the basic circuit using a breadboard. So moving on to the next one, we have blinking of an LED using uh, Arduino. So here we can either do it using a breadboard or directly connect the LED to the Arduino. So I've already made it so that it saves us time. So this is basically the Arduino, and here is, in generally considering the hardware, this would be the USB cable which would be connecting it to the thing. So when you connect this USB into this Arduino, so basically this barrel jack provides a current all over the Arduino. So now I have followed the same protocol here. These are the LED legs. I'll show it to you here. Yeah, so these are the legs of the LED, and so here we have connected. So here we have connected the legs of an LED. The negative, that is the cathode is always connected to the ground, and the anode is we generally connected to a certain pin where we can get an input. So here the cathode is connected to the ground and the anode is connected to pin 13. So as I told, this resistor basically helps the LED to from burning out itself out. So you see, like now we might like remove this and we can connect it. So we sometimes can get a warning. See here we'll get a warning that the, yeah, 1 minute. Yeah, current through the LED is very high, so if it might burn out. So in that way, as this is an online simulator, it will just give you a warning, but it does not happen in hardware, so your LED will just burn out. So this is basically, and here also the value of the resistor can be varied. It's basically these color codes of the resistor that indicate the resistor resistor's value. So here it is around 1 kilo ohm, and I think this is like a very high value, so we can reduce it to somewhere between 100 to 1000 ohms. So generally a value considered for such circuits is 220 ohm. You can see that the colors have changed here, so I'll be explaining the color coding later. So this is what an LED looks like. And so this LED along with the resistor can be set like it's polarized. That means it works only when its legs are connected in a certain way. That is, see, now the positive called anode and the negative called cathode. It should be put in the correct. You guys can do it along with me and ask. Okay, so now
Uh,
I'll,
can I ask a question?
yeah, sure.
Can we keep the one terminal of that resistor to 12 or -1 pin?
Yeah, wait, I'll show you. Suppose we connect it. Now I'll connect to 12. You wouldn't get the value. That's because 13 pin has a built-in LED which tells that there's a LED here. Now I'll show you 1 minute. So yeah, I was coming to that part. So code. I can do have here. So basically, resistor we can basically write blocks of text also. So here we have taken the pin mode output to be 13. We in case change it to 12 and digital write 12 high and digital start simulation. So now basically this Arduino takes in digital values, that is on or off. So basically when we connect it to here, when we connect it to, okay, what, yeah, so basically when we connect it to 13, the digital is in high and low. So here it is using this code. So here we can change the seconds also. Suppose you can change it to high for 5 seconds and you can change it to one low for 2 seconds. So in that way you can like start. You can see the LED blinking for 5 seconds and then it'll turn off for 2 seconds. So in that way, we'll be moving on to our next thing. So the next one is basically connecting an RGB LED with an Arduino. So this is basically an RGB LED with the first terminal representing red, second representing a cathode, third representing blue, and fourth representing green. So generally the cathode we connect it to the ground so that if there's like any extra current, so we turn it off. I'll remake this. You guys can. I'll remake the circuit. You guys can follow along with me. So first, like place a breadboard and then an Arduino IDE. So these are the two basic components you will require in everything. So now you can search for your LED RGB and place it suppose here. So now here we have the thing. So here we'll first connect the cathode to the ground, and then you can connect the blue to suppose. Okay, so first here we have to write. We can first like determine what pins you want to like put your uh, code to. Suppose now I have red, blue, and green. I'll fix my red to pin number 11, for example, and I'll fix my blue to pin number 9, and I'll fix my green to pin number 10. I'm just following the convention like RGB so that we clearly have it. So you can also change the color of this wire. So this is red. This is blue, and this is green. Yeah, so this is the actual circuit. I have to send in some resistance values into the thing so that here, and anyways these resistors are parallelly connected to the RGB LED. So now I can write a code. Now I have the code I have already got the code. So here now I have set my RGB LED. Now the int red pin I have connected it to 11, and the green pin I have connected it to 10, and blue pin I have connected it to 9. You can also like change the variations, that's not the problem. Now I'm using this function called this part called void setup. So I've told you that basically in void setup you're supposed to put in your inputs like what you want as an output, the pins you want as an output. So here I am first declaring a few integers like a few variables, and I'm assigning a few values to that. So those values are nothing but these values I've put in there. So pin mode, I'll use pin mode. That's because that is from where I'm getting an input. So here you'll put the variable and here you'll put like an input or an output. So here I've put in red pin output, green pin will give me another output, and the blue pin which is connected to like 9 will give me another output. So now I've told in void loop you write whatever function or code you want to write. So now here, now the maximum, like the basic colors in a thing, the three primary colors are red, green and blue. So the value of red, green and blue when taken in hexadecimal and converted to normal values can go from 0 to 255. So you can change these colors and you can get anything from 0 to 255. Now when the color is 255, 0, 0, you'll get a red. And when it's this, when the middle part is 255, you'll get green. And when the third part is 255, you'll get a blue. And here I've put some two extra values which gives me a yellow. And similarly, I've changed from 80 and 80 I'll get a purple. So you can put in there anything from 0 to 255. And now here I have put this thing. So here I am basically trying to set the color. So when you want to give a red, you need to do 255 minus red. That is the amount of brightness you will get in that. And we use the analog right thing to set brightness to each LED. So now suppose I'll simulate the code for you guys. Here red, green, blue, yellow, purple and cyan. So these are the colors I have told that I need here, and I have put also a delay in 1000. This is nothing but 1000 milliseconds or 1 second. So you guys can set it like this. So this is the thing you'll get. Okay, guys, I'll move on to the next thing. So next one is we're using a push button in a circuit. So what a push button is, basically when you click on that button, that acts as a medium to light up our LED. So this is what I've constructed. So first, you guys, I'll be going step by step and you guys can do it. So first, you can put your breadboard and you can take your Arduino. And now you can you need a sort of power supply from the Arduino to the breadboard. So that's why we're connecting these extra wires. So basically always the ground is given to the cathode, and the anode gets the positive 5 volt for the current to flow. So first from 5 volt we're sending a red we're sending some current to the positive terminal of the breadboard. So we're basically representing it with red, and then to the negative from the ground. The circuit should always be grounded, like for example for some extra or waste current to pass away. So here I'm connecting the ground. Now I've told you that these parts of the breadboard are being separated. So we also need a way to for some current to pass into this side of the breadboard. So from here we pass some current into this one. Okay, I'm considering you're done with that. So here, basically now you can drag a push button and place it here. So basically when this button is pressed, an electrical connection is made between this power and the Arduino. So, and then as the extra current needs to be eliminated, I am taking a resistor of, you can take like 10k or you can take 10k or some large resistor between the Arduino pin and the ground. So now when you have placed the push button, you always need to connect the diagonals of the push button in order to be connected to the Arduino. So these two terminals could be used for any other use. For example, you could use these two terminals. So now I am connecting one of the terminal into a power supply so that some power can pass through it for some energy for it to work. And here I'm connecting a resistor so that it will protect it from the extra uh, current, so that also the connection would be strong, and some power from ground 13 into this LED. So basically when I start the simulation and click on this, you can see that the LED has light power status high. So I can also do this using a code. So I hope the code is visible. So here I'm basically put a code like You can add whatever comments you want. Basically, comments, it should make it easier for you to understand the code. Now first you can go to variables and you can click on create variable. So now I have created state of the button. So now I'll use state of the button and you can like set it to a certain value. Here I have used the digital pins. So you can use digital pin number 2 and so that it can read its value from digital pin number 2. You guys are not able to follow up with me, you can like take a snapshot. And then I am putting another comment for me to understand that now I'm going to press the button. So here if the state of button is that variable I created or button state or whatever, I have various operators here. So now I'm clicking equal to. Now I'm saying that if the state of this button is equal to high, and then I'm going to set the built-in LED is equal to high. So that is why when I clicked it and click it, the thing is loading. And same way, you can also put in set built-in LED is equal to low, and you can also put some time from controls. So here basically you have like loops. Here you can wait for a certain amount of time. You can repeat the same function 10 times and sort of that. And also you can use your shift button in your keyboard to keep the light on. So now this one, when I press block plus text, it is also converted into a code. So basically, when if you're having a hardware, you can easily download this code and you can upload it into your Arduino software, and that would be easy for you guys to create and put it into your Arduino in case you have a difficulty writing the code. So this is one of the circuits.
What is the difference between digital pins and analog pins?
Okay, so digital pins is that it gives you like two values, either 0 or 1. It is basically working on like a binary basis. Whereas if you go to an analog pin, it keeps giving you different values at different intervals of time. Suppose now I consider from 0 to 1. Digital pins give you the output at 0 and at 1. But whereas I go to analog, it gives me at every one point, like 0, 0.01, 0.02, and you can't tell like how many zeros are there. So at it gives us a value at every interval of time, and I'll be like going on to the next circuit with, and this is basically based on a digital pin circuit based using digital pin. And next I'll, you guys are done, right?
Yes, yes.
Yeah. So now this is basically a potentiometer. This potentiometer has a knob. This extra thing you see here is basically a knob, and by moving these values, you get different values. So here I go to a potentiometer. You can also use a breadboard with a lot, like here in this manner. You can also use a breadboard. Like, wait, I'll show you how to do it in this. I'll be just like showing you the diagram and I'll explain the mechanism in the other one. So now you can like use a potentiometer. So here this is the potentiometer and this is called a wiper. Wiper is something but nothing but it's something which takes an analog values. So here I can go on and connect my wiper to the for analog pin 0, and here I can connect my terminal 2 to uh, cathode and this to my thing. So this is how you generally build it on a breadboard. Moving here, this is nothing but a simple one. Here I am giving the power 5 volt, and then I am giving my wiper is taking in a value of A naught, and my terminal 1 is going to ground. So now if I press start simulation, you can see here Yeah, so here you can see in my monitor, I am not changing it. My potentiometer is giving me the same values at the same point. Now I can start the simulation. See if I am changing the knob values, you can see it was 184, then 205, then 246. So this basically changes the values and it can go on from 0 to 1023. So this is basically used as an analog. You have more analog things which we'll be covering soon, like sensors and all. So basically those also take in analog values. Basically whatever helps you in detecting real time signals, like suppose like temperature, light, and all, potentiometer. All these are taken analog, use analog signals, so they're connected to analog. But when you consider something as a PIR sensor or a motion sensor, these take in digital values. For example, you use motion sensor, it takes either the value of 0 or 1. So basically consider we put in a motion sensor when a person passes through. We put it near a door. So this motion sensor, when a person passes through it, gives us a value of 1. It shows us the value of 1 in serial monitor. But when it's empty, it keeps displaying the value 0. And again someone passes, it displays the value of it displays the value of 0. So now this is what takes in analog. So now this is something called servo motor. It's generally used in like robotic arms and all that. So first you guys can start off by taking an Arduino board and a breadboard. So now first I'm giving a ground and as a 5 volt of power to the circuit, and the same wires I am connecting it over here for some current to pass over this thing. Generally we can use a thing directly like power, ground, and signal. So signal you can generally connect it to any of the digital pin, and the signal you can power you can connect it to 5 volt, and ground you can connect it directly to this ground, and here you can connect the power and you can connect the signal to any one of the digital pins. So that will be the basic thing. Here I've used a breadboard, so here I need some power. So basically I'm getting the power from this 5 volt into this breadboard. So now we know the power which is entering from this 5 volt, it shares across all over these rails. It shares across everything. So now when I connect here, now my current passes through this way. I'm getting some current into this. Now here I have my ground terminal which is fixed in the same way, and here I have my signal. I need a certain place to for an input signal, so here I put in my signal. Now the code part. So now you guys can go to variable and create a variable. Now it is case sensitive. I have just put a variable POS that like basically shows like the position of the servo motor. So now control here, basically we're going to count like if it's moving up or down. So it basically it doesn't rotate 360, this servo motor, it rotates 180. So first now I'm telling count up down, you have this thing. So now I'm telling count up by 1, that is move up by 1 position. For my position changes from 1 degree to 90 degrees. And also now this servo pin signal comes from second pin. So that's why I have put in my rotate the servo pin on 2 to POS degrees, and this POS degrees I have given here the values, and I have told wait for 40 milliseconds, and the same thing I am giving for my other one. Here I have only given from 1 to 90 degrees, and I also that will be like halfway. So suppose I want my motor servo motor to return its way back. So now I can give 90 to 180. Now I'll show you guys the code start simulation. Now you can see it is moving here, and now you can see it moves like slower. This is because I have first given it to rotate from 1 to 90 in 40 milliseconds, and then I have asked it to rotate it from that 90-degree position to 180-degree position in 100 milliseconds. You guys can see. Now I can change my code. Suppose go from 0 to 180 in 40 milliseconds, and come back from 180 to 0 in 100 milliseconds. Code start simulation. So this is basically the circuits we have covered today. And now you guys there is this software called Audio Block, which the link is in the chat box. And I'll basically teach you how you can link audio blocks to this one. It basically makes your easy thing easier. So basically now you guys can open this thing. I'll just show you now. In case you don't understand, you can ping me again. So here you can go to preferences, and basically you get this code here. So you can copy that code and open your this files explorer. So when you open this, go to your downloads or something, and click that code. So basically you and enter it, you'll get here. Now I want you to like create a new folder here. Create a new folder named, suppose, tool. So basically when you click on this tool, I have created already a thing called tools. So I'll through audio block tool. Now I have made, see, like in Arduino I made a folder called tools, and in tools I have again made an thing called audio block tool. So this basically makes it easy for me to differentiate different tools. So here, after you guys click Arduino tool, you can after you have downloaded, you'll basically get it in the form of jar file. If you paste the thing here, and you can like refresh your page, and now when you go to tools, audio block, so this basically opens the same control pins, analog, everything, and you have like few sensors here. So basically these are useful when you're using, suppose you're using an ultrasonic sensor as hardware, but you're finding difficult to write the code. So you can like drag and drop, you can put in your code here, and when you say upload to Arduino, your code, it will directly convert your block diagrams into code, and it will upload here. So this is it for today. I'd like to hand over the session to Saket.
So we know like how Python is developed, how Python is working. Why we use Python? We know that it's easy to write the code, simplicity, easily you can understand. So just now you saw the Arduino programming. For that you see the how long write the code. But what if you use Python for that? It's just a matter of few lines, 3-4 lines only. So let's see how the MicroPython for a microcontrollers. About me, I'm one of the DSC technical member. I'm also a phase executive, and I'm also part of the Amata Rover team. And also, I'm a student at IBM quantum computing school. And like projects, I'll do like more about the quantum computing and IoT, and also Android OS development and web development. Yeah, currently So I being given a quantum computer, so I can play with that and doing coding on that. It's cool actually. So let's start it. So here's small code about MicroPython. So MicroPython is open source. What do you mean by open source? That means you can see the source code entire thing, like how the things are working in the ground level. I mean the source level. You can open it and you can see whatever stuff you want. So MicroPython is just implementation of Python 3. That means all the syntax of Python will be in the MicroPython also. But it's optimized for microcontrollers. Let's see what kind of optimize we did it. So currently we can run MicroPython on these four boards. One is the Pi board and one is ESP8232 and 8266 and the Raspberry Pi Pico. About the Pi board was developed by the MicroPython community and ESP8266 and ESP32 they have a built-in Wi-Fi, so most people use for the IoT things that thing. And the Raspberry Pi Pico, it's a new thing which was released in this January 2021. Uh, can you see the pointer?
Yes, yes.
Yeah. So if you see the boards, this is the Pi board, um, this is the ESP, and it's a micro bit board. We can go through, but people cannot understand easily. Fine. Let's next thing. So as I mentioned, it's a full implementation of MicroPython and the Python 3 is like how we like import max, import all the syntax will be same, but all the code is connected to C code actually, basically. It has a built-in garbage collector. Why we need a garbage collector? So we have less RAM and a less memory actually, and even the less ROM. So for that, we have to create the RAM now. So we have a built-in library. You can collect and you can free the memory how much you want. We have. So it's just like a mini operating system actually. So it's help to you clear cache. You can run the task. Even just now I mentioned the Raspberry Pi Pico. It has two processors actually. That means you can do context switching. All the stuff you can do with the laptop you can do, but not so big. But it's small scale. Okay, fine. Uh, let's try hands-on how the MicroPython works. Just print hello. So even you can interact here also, like a real time. Let's say I want to uh, 1 plus 2, 3. Even I can do multiplication also. Even I can do power also. So that means you can do like all the Python's thing here, but in an optimized memory. That means I cannot do the biggest number into power of 10 because it's take time because it has a limited RAM and a limited thing. So it's taking a time because if you see the board configuration, I have 64 KB of RAM, and you see the clock speed, it's increasing. That's a okay. It's take a while. Let's stop this. So you understand now. So in the smaller device, we have constraints of memory, constant of the processing power. So we have to use the memory and the process carefully. That's why we have a built-in libraries to free up the cache, all the stuff we have to do. So this is the basic high-level program. So can you see the diagram clearly?
Yeah.
Yeah. So if you see here, this is a micro USB. You can connect your phone here on the phone charger pin. Even you could connect your SD card also, I mean the micro SD card, and all these are pins, same as Arduino, but say small number of pins basically. If you see here, and this is the LED one, this is the LED 2, LED 3, LED 4. So now here we have 4 built-in LED, okay, and you have 2 switches also, okay. So we use this button for a reset. Let's why use reset? Let's say you done the code. Maybe you want to rerun the code again from the starting. Then if you press this reset, all the code will run from again. That means just basically you're rebooting the system. So this button we use for flashing actually. Flashing in a sense, you want to write the code into this microchip now. So at that time we press this button, then we write the code actually. So more about this, it's required all 3 volts and 3 volts to 16 volts on the input, and the maximum volts is required 2.5 amps. So it's less than an Arduino power requirements. Okay, now we'll try the LED thing. So if you see a code, I'm importing time. So I'm using time to make a board sleep for a second. Here I'm thinking half a millisecond. That means I'm running a for loop here. See, it's just a normal Python code only, and it's a PyBoard. It's a built-in library to control the I/O pins in the board actually. Then it's I run a script. If you see here, a red LED is blinking here. I now you can see the thing which loop is running now. Run the script. Hello 10, it's printing this here, and simultaneously you can see the board is blinking. See how small code is, just 7 lines hardly took me on the LED and writing the loop. So that's easy how MicroPython is. So it's so on continue. Let's stop the script. Yeah, see, same button, it's a reset button. See, when I press the reset button, all when it's the starting point. So that's it. So as I mentioned, we have 4 LEDs now. If we change to 2, right, run the script. See, now the green is blinking. That's it. Like we have 4 built-in LEDs. You can try the 4 LEDs. Run the script. Now you can see this LED will run it. See the blue is running the LED. So even you can run the all LEDs, like what you can do I mod 4. I mod 4. Run the script, finish. Now you can see all the lights will blink. Can you see that all the lights are blinking and offing off one by one? Yeah, fine. So let's try. Okay, can you see a small motor here with the knob pointing to upwards?
Yes, yes.
Yeah. So if you see, it says minus 90 to 90. So it's just like a motor, we can turn into any angle. Let's say if I wrote this small script, so I'm thinking servo 1, I'm making servo 1. I want to move the angle to it's 45 degrees. Okay. So which side you think it will move? This is positive, this is negative.
Pause to say.
Yeah. Let's run the script. See, it's moved to 45 degrees. Let's say I want to go to minus 90 degrees. From this point, I have to go to minus 90 degrees. Run the script, it's going backward to 90. It's come to 90. So if you see that its maximum range is minus 90 to 90 degrees only. That means have the total 180 degrees freedom actually. And this tell you how speed should be smooth. house speed. Let's say if I keep 1000 and if I keep 90, see it's moved 2 bars fast actually. Okay. Now if I keep 0 and run the script. See, that's simple. If I want to add under servo, can I add a under servo motor? No. Okay, fine. I cannot add a under servo motor. So maybe you guys understand now, like how to control a servo motors basically. So that's easy. So we'll see in the upcoming things how what is MicroPython, how we can connect the cloud, and how we can control the RC card using the cloud things. Like last year I did a project also. You can see that, you can check the thing. So this is the RC card which you can control from the over the cloud actually. So I use a Blink as a my cloud service, and I use a MicroPython to control a remote car. If you have any doubts, you can contact me.
Thank you guys. Thank you for joining the session. I'd like hereby end this session, and we have a next session on sensors and actuators. We'll be sending out the link soon. Thank you.
We'll be right back.